So next topic in the measure theory that we will do today is the Lebesgue measurable set. Lebesgue measurable set. So what is when a set is said to be Lebesgue measurable? When a set is said to be Lebesgue measurable, a set E is said to be Lebesgue measurable. मैं short form में लिख रही हूँ. This is L and this is M. Is said to be Lebesgue measurable if for each set A contained in R, we have the outer measure of A is equal to the outer measure of A intersection E plus outer measure of A intersection E complement. सेट E को काउंटेबल मेजरेबल प्रूव करना है, लेकिन उसके लिए एक सेट A चाहिए जो रियल नंबर के अंदर पड़ा हुआ है, और अगर वो सेट इस कंडीशंस को सेटिस्फाई कर देता है, दैट इज उस सेट का मेजर द सम ऑफ द आउटर मेजर ऑफ दीज टू सेट्स, देन द नॉट द सेट A, then the set E is said to be measurable, right? Here the set A is called the test set. Here the set A is called the test set because it is used to, as it is used to test the measurability of A. As it is used to check the measurability of E, right? So how you will express it? दो चीजें बताई थी आपको. एक होता है काउंटेबली सब एडिटिव, एक होता है काउंटेबली एडिटिव या सिंपल एडिटिव फाइनाइटली, और काउंटेबली साथ में क्या होता है फाइनाइटली. ठीक है जी. और फाइनाइटली एडिटिव. फाइनाइटली एडिटिव में आप क्या लेते हो कि एम स्टार, अगर हमारे पास सी एक सेट है विच इज द union of two sets and A intersection B is not equal to 5, then M star C is equal to M star A union B, which is equal to M star A plus M star B. ये एक रिजल्ट आता है. अदरवाइज आउटर मेजर क्या किस प्रॉपर्टी को सेटिस्फाई करता है? M star C, राइट? दिस इज लेस देन और इक्वल टू M star जो भी है, या M star या मैं सीधा लिखूं M star A union B, this is less than or equal to M star A plus M star B. इस तरह की प्रॉपर्टी को सेटिस्फाई करता है. ठीक है. सो ऑन द बिहाफ ऑफ दैट अब A देखिए, अब A जो है A M star A फाइंड आउट कर रहे हैं. ठीक है. वो किसके आउटर मेजर से बना है? A इंटरसेक्शन E प्लस M स्टार A इंटरसेक्शन E कॉम्प्लीमेंट. इसका मतलब ये हुआ कि ये दो का सम आ रहा है. आपने इसको ऐसे लिखा है, एक्चुअली ये है. इसका मतलब ये हुआ कि A जो है ये दो के यूनियन से बना है. A इंटरसेक्शन E यूनियन A इंटरसेक्शन E कॉम्प्लीमेंट, ये दो के यूनियन से बना है, राइट? सो अब जब दो के यूनियन से बना है, वैसे हमें नहीं पता भी इसके बीच में ये आपस में अगर इक्वालिटी है तो इट मींस दे have their intersection is equal to 5. So M star A is finitely subadditive, right? So therefore M star A intersection E union A intersection E complement. This is less than or equal to M star A intersection E plus M star A intersection E complement. Directly हमने किसकी प्रॉपर्टी लगा दी, because M star is finitely subadditive. M star is finitely subadditive, right? सो एक कंडीशन हो गई है क्या इसमें, इक्वालिटी। इसका मतलब अगर हमें मुझे ये प्रूव इक्वालिटी लेके जानी है, इसका मतलब इट इज सफिशिएंट टू, ये तो हमेशा ही होल्ड करेगी, इट होल्ड्स ऑलवेज। So which condition that we have to prove that a set is a measurable set? That M star E is greater than or equal to M star A intersection E plus M star A intersection E complement. So in order to prove that a set is a measurable set, we are only need to show that M star A is greater than or equal to M star A intersection E plus M star A intersection E complement. क्यों? क्योंकि less than or equal to वाली प्रॉपर्टी हमेशा ही होल्ड करेगी, क्योंकि आउटर मेजर जो है इट इज फाइनाइटली subadditive, right? So I'm elaborating the definition again. So it implies what we can say here. So the measure of the definition of measurability, what it says. So definition of measurability says that measurable sets are those bounded or unbounded, which split every set, measurable or not. देखो बात सिर्फ मेजरेबल की कर रही, ई एक मेजरेबल सेट्स था, वो बाउंडेड है या अनबाउंडेड है हमें नहीं फर्क पड़ता, वो स्प्लिट करता है एवरी सेट को, ठीक है जी, विच स्प्लिट एवरी सेट, वो मेजरेबल है या नहीं है, इनटू टू पीसेस, विच स्प्लिट एवरी सेट, कौन सा सेट, ए, इनटू टू पीसेस, that are additive, additive में इक्वालिटी आती है, सब एडिटिव में लेस देन और इक्वल टू आता है, with respect to the outer measure, so उन्होंने कहा ई मेजरेबल तभी होगा जब एक सेट स्प्लिट हो सकता है into टू पीसेस, इस सेट को स्प्लिट कर दिया दो पीसेस में, ए इंटरसेक्शन ई एंड ए इंटरसेक्शन ई complement, which are additive, means which is equal to the sum of the measures, are additive with respect to the outer measure. So this is all about the definition of a measurable set. अब ए की जगह पे 5 भी हो सकता है, 8 भी हो सकता है, कोई भी सेट हो सकता है. Now the question is, हमें क्या करना है? We just have to split any set A into two pieces which are additive with respect to the outer measure. So now I am coming to the properties of measurable sets. Properties of measurable sets. So you will write in the box properties of a measurable set. Measurable sets. Number one. If E is measurable, then so is E complement. If A is measurable, then so is E complement. अगर कोई set measurable है तो उसका complement भी क्या होगा? Measurable. मान लिया, since E is a measurable set. Since E is a measurable set, E measurable है, then by definition of the measurable set, there exists for any set A, therefore for any set A contained in R, क्या होगा? M star A is equal to M star A intersection E plus M star A intersection E complement. ये रिजल्ट E के लिए है, मुझे पहुंचना है E complement, right? So can I write like that? M star A is equal to, इसको पहले लिख दिया, it implies A intersection E complement, right? इसको मैंने इधर लिख दिया, अब इसको मैं इधर लिख रही हूँ, M star A intersection E को can I write E complement its complement, right? अब जो काम यहाँ set E measurability के लिए कर रहा था, वही काम यहाँ पे कौन कर रहा है? E complement. Set E measurable है तो एक set लिखा है, उसका complement लिखा. अब मुझे प्रूव करना है E complement, तो यहाँ E complement आ गया, set E complement है और E complement का complement ले लिया. So what does it states? It implies the set E complement is measurable. That's all. कुछ भी नहीं था. Just we have to interchange the position of E and E complement. Now, property number 2. Second property states the set phi and R are measurable sets. Set phi and R are measurable sets. So we were doing the properties of measurable sets. Second property. I am writing here in the short form measurable set. Second property, the set phi is measurable, right? If A can be expressed as A union phi, if A can be expressed as A union phi and A union phi complement, then we can say that the set phi is a measurable set. देखो आपको प्रूफ क्या करना है? To prove M star phi, M star A. This is equal to M star A intersection phi plus M star A intersection phi complement. This you want to prove, right? ये left hand side, right hand side की इक्वल आनी चाहिए. So we will consider what is A intersection phi. We will find out A intersection phi complement, and then we will take its M star. ठीक है जी? Now, what is A intersection phi? When we will take the intersection with set, that is equal to phi. It implies M star A intersection phi is equal to 0. Now A intersection phi complement. What is phi complement? It is the whole space R. And A intersection R is A. It implies M star A. It implies M star A intersection phi complement is equal to M star A. ठीक है जी? Substitute in star. It implies M star A is equal to, this is equal to 0 plus M star A. ये लॉजिक हो गया प्रूव. It implies m star a is equal to m star a, which is true. Which is true. Therefore, what we want to prove that? What we want to prove that? M star a is equal to m star a intersection phi plus m star a intersection a. Complement, it implies phi is a measurable set. यहाँ आप लिखेंगे टू प्रूव फॉर एनी सेट ए कंटेन इन, ये ऐड कर देंगे. ठीक है जी. नाउ वी विल प्रूव द थर्ड प्रॉपर्टी. प्रॉपर्टी नंबर थर्ड. थर्ड प्रॉपर्टी. थर्ड प्रॉपर्टी क्या है? Prove that R is measurable. ठीक है जी. So the set R will be measurable if for any set A, m star A is equal to m star A intersection R plus m star A intersection R. इसको हम if and only if से कर लेते हैं. ठीक है जी. if and only if. जो आंसर एंड में आएगा अगर वो हमारा होल्ड कर जाता है, मतलब ये कंडीशन होल्ड कर जाएगी. सो m A intersection m star A intersection R, this is equal to A. What is R complement? This is equal to phi. If and only if m star A is equal to m star A plus m star phi. और m star phi क्या है? 0. If m star A is equal to m star A plus 0. So if m star A is equal to, which is true, तो सेम क्वांटिटी इज इक्वल हो सकती है. ठीक है जी. which is true. Therefore, what you will write at the end, therefore the set R is a measurable set, right? So next property we will do property number 4. Property number 4. Properties of measurable sets. So what it states, if outer measure of a set is 0, then E is measurable. E is measurable. But यहाँ measurable doesn't mean you must have the finite answer. It means that if the another set A can be divided into two pieces which are additive with respect to the measure, then we will say that the set is measurable. ठीक है. उसका आंसर infinite भी आ सकता है. अब जिस सेट का मेजर 0 है हमें प्रूव करना है वो सेट क्या है? मेजरेबल है. सो लेट्स कम टू इट्स प्रूफ. लेट A contained in R be any set. ठीक है जी. देखो दो चीजें हैं, तो वन इज A intersection E, the other is A intersection E complement. Now A intersection E is always contained in E. It implies m star A intersection E is less than or equal to m star E, and that is equal to 0. ठीक है. And A is always superset of A intersection E complement. It implies m star A is greater than or equal to m star A intersection E complement. So you can write it implies m star A. यहाँ पे कुछ नहीं है तो मैं यहाँ पे क्या लिख दूंगी? 0 plus M star A intersection E complement, right? And this is again greater than or equal to 0. 0 is यहाँ से आप लिख सकते हैं इस लाइन में, that is 0 is greater than or equal to M star A intersection E. तो यहाँ पे वही 0 की जगह पे क्या लगा देंगे, M star A intersection E plus M star A intersection E complement. So we have in the definition, it is sufficient to prove that M star A is greater than or equal to M star E plus M star A intersection E complement. It implies E is a measurable set. So in other words, we can say that if the set has the outer measure 0, then it is measurable. If the set has outer measure 0, then it is measurable. Then it is measurable. So for example, let's do its example. For example, set of natural numbers have the measure 0. So therefore, set of natural numbers is measurable. ठीक है जी? Set of rational numbers has a measure 0. It implies it is measurable. Set of integers have the measure 0, then it means it is measurable. Set of Cantor set has a measure 0. It means it is measurable. So there is no direct relation between measurability and countability. हम सीधा नहीं कह सकते हैं, ठीक है? कि जो uncountable है देखो वो भी measurable हो रहा है, जो countable है वो भी measurable हो रहा है. So इसमें कोई relation नहीं find out कर सकते. So these are the examples that you can note कि the set of natural numbers, set of integers, set of rational numbers, set of all algebraic numbers, set of Cantor set itself, they have the measure 0. So these are measurable sets. So this is all about today's topic. I hope you have all everything is clear to